Hey guys, Mrs. Stans here. So we're on lesson 10. This is like when things get a little more complicated. I really need you to focus. I need you to send me any questions if you have them. All right, so finally today we're using our calculator to actually decide how strong a correlation is. What we're doing is we're finding something called the correlation coefficient. And that correlation coefficient we like to call the R value. And that's because when we use our calculator, it's represented by the letter R. It tells us how strong a correlation is. So here on number 2, for our getting ready, it tells you to print or copy the notes. So I will provide them on our Google Classroom so that you can print or copy them. But really, what we've learned is that the slope of the line will tell us whether the correlation is positive or negative. The correlation coefficient, that's what we're learning about today, is a way of measuring the goodness of fit, like how good of a fit something is. It indicates whether the regression really fits that equation that we find very well or not. And some things that you need to know is that the correlation coefficient, which we call the R value sometimes, is always between -1 and 1. -1 means that it's slanting downward. It has a negative uh, correlation. That's perfect. A +1 means it's slanting upward and it has a correlation that is positive and is perfect. So anywhere in between there is the correlation coefficient. The closer the correlation coefficient is to 1, the stronger the correlation. So we like to say that if the absolute value of R is greater than 0.8, it's strong. If the absolute value of R is between 0.5 and 0.8, we call it moderate. And if it's less than 0.5, we call it weak. So prior to today, I've just been telling you that the closer the points are to the line, the stronger the correlation, and the farther the points are from the line, the weaker the correlation. So now we're actually going to be able to see how strong or how weak it is by looking at a number. The closer the points are to the line, the closer that number will be to 1. It'll be like 0.8 or greater. The farther the points are from the line, the farther away from 1 it will be. It'll be closer to 0, I should say. Therefore, the weaker the correlation. So we do have a do now, and I will provide you with the answers from the lesson prior to this. And we will be talking about the correlation coefficient, what it actually means, and your homework is to do the problem set. So in the last few lessons, we've worked with generating lines and curves of best fit for bivariate data. And in every circumstance, even though the data didn't fall on a straight line or on a perfect curve, it sure has been close, right? And we've never answered the question about how well it actually fits. So in order to do today's lesson, we have to put our calculator into a certain mode. We have to turn our diagnostics on. So you need to follow these keystrokes. So I'll do it right here in front of you, but also it's printed on this lesson so you can refer back to it. So we have to hit second. I have to turn it on first. Second. One moment. Here we go. Second, 0 gets us to the catalog. And in the catalog, it's an alphabetical order list. We want to move to diagnostics on. So first you see diagnostics off and then diagnostics on. So we need diagnostics on, and then you have to press enter. And then you have to press enter one more time so that it says done. And there we go. Our diagnostics are on. Once the diagnostics are on, we will see our R value. So in the following exercises, 4 data sets with equal x values are given to demonstrate different positive correlations. And for each of them, we're going to enter the data, we're going to look at the scatter plot, and we're going to record the R value. So let's do this together. So the x values are the same always, 2, 5, 8, 11, 15, and 18. And that goes in our L1. In our L2, we're going to put the numbers that we see. So for part A, I see a 4, 13, 22, 29, 43, and 52. Let's first take a look at that scatter plot. So remember, second stat plot, go to number 1, make sure your plots are on, make sure you choose the scatter plot, and let's do zoom stat. Notice it is a positive correlation. Looks almost perfect, right? It's almost a perfectly straight line. Looks like maybe it's a tiny bit off. Maybe it really is just perfect. But anyway, if I were to do a sketch of that plot, I would do something like that. But we need to learn how to find the R value. So we're going to hit Stat. We're going to go to Calc. Since it looks like it's a straight line, we're going to do a linear regression. We're going to go to number 4. You need to move down to Calculate and then Enter. And since we turned our diagnostics on, you now see this new data represented in R squared and an R. Notice the R says 0.9989891246. So if I were to round to the thousandths place, I'd put 0.999. R is about 0.999. So that is so close to 1, like the notes that I told you that you had to copy, that this represents a very strong correlation. Anything 0.8 or greater is strong. Let's take a look at B. We expected it to be strong, by the way, because it's almost a perfect straight line. So the x values are still the same, 2, 5, 8, 11, 15, and 18, but I'm going to change my y values. So I'm going to change my L2. Let's take a look at that scatter plot. So second y equals brings me to stop plot. It's already on the scatter plot. zoom, stat, and I could see it's still a positive correlation, but it's a little more spread out. If I were to try and copy that information onto my paper, I would see something like this. Okay, it's still positive. But I'm expecting the R value to not be as close to 0.999 since the points are a little more spread out. Let's see what that R value is. So stat, calc, linear regression is number 4. You move down to calculate. And notice it's still pretty strong, but not as strong. 0.930. On C, what I got on here now. The X values are the same. But I have to change my Y values. We'll take a look at the scatter plot. And I guess they're even a little more spread out. Still positive though. If I were to look at the R value, I have to go over to calc and do a linear regression. Notice it's 0.776. I would consider that moderate. Because it's less than 0.8. And then the last one, the X values are the same. We just have to change our Y values. And let's go look at that scatter plot by doing a stat plot. And zoom 9. They are pretty spread out. I don't know. It's like really pretty weak. I don't even know if I would consider it positive. It might be considered a no correlation. Let's see what the correlation coefficient looks like. We go over to calc and we do a linear regression. Oof. See how close it is to 0? It really is pretty much a no correlation. 0.133. would really consider this a no correlation. So close to zero. So how does the correlation coefficient quantify the fit of a positive correlation? And what I would say is that the closer it is to 1, the better the fit. So in exercise 3, the following data set is that of two variables that have a negative correlation. Enter the data, produce a scatter plot, and record the R value. How is the negative correlation reflected in the R value? So we have to clear both our L1 and L2. Remember, clear, don't delete. Oh, you know what? I didn't have to clear the X value. I see it really is still the same as before. And if we take a look at the scatter plot, oh, what did I do? Aha. So I'm glad I made an error. Sometimes this happens. When I look at my L1, there's less pieces of data than in my L2. So somehow I missed something. 2, 5, I'm missing my 8. And my L2, in my L1, I made a mistake. So I have 2, 5, 8, 11, 15, and 18. So the number of pieces of data have to be the same in your L1 and L2. So I was getting an error message because I was actually missing a number. So you can see that these points are going in a downward direction, which represents a negative correlation. It looks like a pretty strong correlation. They're almost in a straight line. If I were to record this, there's like this one point that's a little off, but all the rest seem to kind of be in a straight line. If we do a linear correlation by going over to calc and going to number 4, and you go down to calculate, you can see it is strong, but do you notice that negative sign in front? Negative 0.945. So it's so close to negative 1, therefore it's very strong. The negative represents it going downward. If it's positive, it represents it's going upward. So this has a very strong negative correlation. And it's because it's going downward. Okay, the negative sign tells you which way the slope is. Next page. Given the scatter plot shown below, which of the R values would most likely represent the correlation between the two variables? So something you should recognize is it's going upward, so it has to be positive. So let's get rid of choice 4. It's not absolutely perfect, so it can't be choice 3. It is pretty strong if you ask me, so it's not choice 2. It has to be choice 1. Exercise 5. Which of the following scatter plots would have a correlation coefficient closest to -1? So it has to be going downward. This looks like no correlation. This looks like it's going upward, not so strong. Both of these are going downward. They said closest to -1, which means the points have to be more in a straight line rather than more spread out. So it has to be choice 4. Exercise 6. There are 2 primary types of crude oil sold in the world: West Texas Intermediate and Brent crude. Each is priced differently on a daily basis, and each has a correlation with the average price per gallon for unleaded gasoline. The 2 linear regression models, along with their R values, are shown below. So Brent crude oil has this linear regression, this linear equation, whose R value is this, while WTI has this linear regression, whose R value is that. So this R value is a bit weaker than this one. They're both pretty strong, though, if you ask me. Give a prediction for the price per gallon of unleaded gasoline Y on a day when the price for WTI is 103 and the price for Brent is 109. Which model did you choose and why? So I had just said that this one has a stronger R value. So when it says which model did you choose and why, first of all, I'm going to choose Brent because its correlation coefficient is higher, therefore it's more reliable. And I'm going to substitute the 109 in here because for Brent it's 109 for the X value. And that will find my Y value. So you could just use your calculator. $3.762. They are asking for the price per gallon. So money usually doesn't have 3 decimal places, so I'm going to say it's about $3.76. And I'm choosing Brent because its correlation coefficient is higher. And that's that. So today, not so bad, hopefully, as long as you understand how to find your correlation coefficient and you know that the closer it is to 1, the stronger it is. Good luck, ask me any questions, and I'll talk to you soon. See you, bye.